Hi student, welcome to my YouTube channel. Today we solve problem on unit differentiation from mathematics part second, exercise 1.1, page number 12 from board book. And here problem number fourth, we solve problem number 4. And problem number 4 is, again in this problem, we find dy by dx. So right here, find dy by dx. If y is equals to, y is equals to under root 10 root x. This function is given. And we find here the derivative of this function. Find dy by dx if y is equals to under root 10 root x. That is, differentiate these functions with respect to x and find out here ddx of y, that is dy by dx. So first we write here the given function. So we write here given function, and given function is y is equals to under root 10 root x. Differentiate both sides with respect to x. Differentiate both sides with respect to x. Here we differentiate both sides with respect to x. Then we find here dy by dx. So here ddx of y, derivative of left hand side. In left hand side y is present. And we find here derivative of y, that is derivative of y with respect to x. So we get ddx of y, dy by dx. So we write here dy by dx, dy by dx, which is equals to here ddx of this function. So write d by dx of, and here function is root 10 root x. So we write here root 10 root x. Therefore here dy by dx, which is equals to dy by dx is equals to here ddx of root 10 root x. We find derivative of these functions, and for finding out the derivative of these functions, we use here the formula ddx of root fx, 1 by 2 root fx into f dash of x. And here f of x is, this is f of x. 10 root x is f of x. This is f of x. Therefore, here, by using the result, ddx of root fx is equals to 1 by 2 root fx into f dash of x. And fx replaced by 10 root x. Fx replaced by 10 root x. So 1 by, right here, 1 by 2. So right here 2. 10 root x, here 2 root 10 root x 1 by 2 root 10 root x into ddx of in bracket here 10 root x ddx of 10 root x. Therefore, here up to this dy by dx is equals to 1 upon 2 under root 10 root x as it is. So write this here. This is as it is. into, we find here ddx of tan root x. So by using the formula ddx of tan fx, sec square fx into f dash of x. Similarly here, sec square root x, here sec square root x. So we write here sec square root x into ddx of root x into ddx of root x. So we write here ddx of root x. Again, we repeat this. dy by dx is equals to 1 upon 2 under root tan root x here as it is. ddx of tan root x sec square root x into ddx of root x. Because here we use the formula ddx of tan fx sec square fx into f dash of x. Therefore, here, again here, up to this step as it is. So we're at this. Then we find here a ddx of root x, and this is the standard function. By now the ddx of root x is equals to 1 by 2 root x. So right here, 1 by 2 root x, 1 upon 2 root x, 1 by 2 root x. Therefore here, required derivative of the given function is, that is dy by dx, which is equals to sec square root x into 1 into 1. So sec square root x. So we write here sec square root x as it is. In numerator, here we write sec square root x. In denominator, this 2 into 2. So we write here 4. We write here 4. Root x. So we write here root x into root of tan root x into root of tan root x, that is multiplications of the denominator, root of tan root x. Again we repeat this, 1 into sec square root x into 1, so sec square root x, 2 into 2, 4, this root x here as it is, under root tan root x as it is, and this is the required derivative of the function y is equals to under root tan root x. That is here by differentiate under root tan root x with respect to dx, and we get here dy by dx, and dy by dx is sec square root x upon 4 root x into under root tan root x. In this way, here we solve the problem number 4 from exercise 1.1. And hereby request you, if you like my video, please subscribe my channel and press on bell icon. Next, that is problem number 5. So it's all here problem number 5. Again, in this problem, we find dy by dx. We find here dy by dx. Find dy by dx if y is equals to here a given function is quart cube log of x cube, quart cube log of x cube. So right here log of x cube. Here function is given quart cube log of x cube, and we find the derivative of this function, that is differentiate these functions with respect to dx and find out dy by dx. So again we write here the given function, and given function is This is the given functions. Y is equals to quad cube log x cube. Differentiate both sides with respect to x. Differentiate both sides with respect to x. Then derivative of y, that is dy by dx, that is differentiate y with respect to dx. So we get dy by dx, dy by dx, which is equals to d dx of given a function, that is given the right hand side function. And when I here the right hand side function, that is ddx of quad cube log x cube. So right here quad cube log x cube. Therefore, dy by dx is equals to ddx of quad cube log x cube. So here we use formula. This quad cube log x cube can be written as quad of log x cube whole cube. And then we use here the formula ddx of fx to the power n. N fx to the power n minus 1 into f dash of x. And here fx is replaced by quad log x cube. Fx is replaced by quad log x cube. Again, we repeat this. This quad cube log x cube can be written as quad of log x cube whole cube. And then we use here the formula ddx of fx to the power n fx to the power n minus 1 into f dash of x. So we write here by using this formula here 3, here 3, then quad 3 minus 1. So quad square. So write quad square. This log of x cube as it is. This log of x cube. 3 quad 3 minus 1, that is 2. So quad square log x cube into ddx of quad of log x cube, because fx replaced by quad of log x cube. So right here into ddx of right here quad log x cube, quad of log x cube. Therefore, here dy by dx, which is equals to 3 quad square log x cube as it is. So right here quad square log x cube as it is. Into here, into, we find here ddx of quad log x cube. We find here ddx of quad log x cube by using the formula ddx of quad fx minus cosec square minus cosec square fx into f dash of x. So here we write minus cosec square fx, and fx is this, that is log x cube, log x cube into ddx of log x cube, into ddx of log x cube, dx of log x cube. So right here log x cube into ddx of log x cube. Therefore, here dy by dx is equals to, up to this step, minus 3 quad square log x cube cosec square log x cube as it is. Up to this step as it is. Then we find here ddx of log x cube. So we use here formula ddx of log fx. 1 by fx into f dash of x. Similarly here 1 by x cube into ddx of x cube, that is 3x square. ddx of x cube 3x square. So 3x square upon x cube. So we write here ddx of log x cube, ddx of log x cube by using the formula ddx of log fx, 1 by fx into f dash of x. Similarly here 1 by x cube. So right here x cube into ddx of x cube, ddx of this x cube. So right here x cube. We use here the formula ddx of log fx, 1 by fx into f dash of x. Again here, up to this step, as it is. Here as it is. Next we find here ddx of x cube. And ddx of x cube by using the formula ddx of x to the power n, x to the power n minus 1. So 3x to the power 3 minus 1, that is 3x square. So we write here into 3x square. So right here 3x square. Therefore here this x square and here from this x square cancel. That is x square upon x cube. So x square get cancelled. So here remaining is x. So 3 into 3 minus 9. 3 into 3 minus 9. So right here is equals to minus 9. Cot square cosec square log of x cube up to this as it is. So this is as it is. Upon here remaining is x. So we write here in denominator we write x. Right here x. And this is the required dy by dx. This is required dy by dx of the given function y is equals to cot cube log x cube. In this way, we solve the fifth problem in exercise 1.1 from board book, mathematics part 2nd. Next, again we solve one problem, and problem number 6. So here we solve problem number 6. Again in this problem we find dy by dx. Find dy by dx if y is equals to 5 to the power sine cube x plus 3. 5 to the power sine cube x plus 3 is the given function y is equals to 5 to the power sine cube x plus 3. And by finding here dy by dx, that is differentiate these functions with respect to dx. So first we write here the given function. Given function is here. We write given function y is equals to 5 to the power sine cube x plus 3. Differentiate both sides with respect to dx. Differentiate both sides with respect to dx. Then here dy by dx is equals to dy by dx is equals to, that is derivative of y with respect to dx, ddx of y, that is dy by dx is equals to ddx of given function 5 to the power sine cube x plus 3. So right here 5 to the power sine cube x plus 3. Therefore, dy by dx LHS as it is, dy by dx, which is equals to here ddx of 5 to the power sine cube x plus 3. And here we use one standard result, that is ddx of a to the power fx, ddx of a to the power fx. So a to the power fx into log a into f dash of x. Again, we repeat this standard result. Remember this result, ddx of a to the power fx, where a is constant, here phi is also constant. A to the power x into log a into f dash of x. And here fx replaced by sine cube x plus 3. So 5 to the power sine cube x plus 3. So right here 5 to the power sine cube x plus 3 into log of 5 into f dash of x, and here fx is sine cube x plus 3, that is ddx of sine cube x plus 3. So right, ddx of sine cube x plus 3. Therefore here again we repeat this step, dy by dx is equals to ddx of 5 sine cube x plus 3. And this is of the type, that is ddx of a to the power fx, a to the power fx into log a into f dash of x. Similarly here 5 to the power sine cube x plus 3 into log 5 into ddx of sine cube x plus 3. Therefore dy by dx which is equals to 5 sine cube x plus 3 into log 5 up to this step as it is. So right here up to this functions here as it is. Then we find here by using the addition rule, ddx of sine cube x plus ddx of 3. We find here ddx of sine cube x. That is here we use the formula ddx of fx to the power n fx to the power n minus 1 into f dash of x. And here fx is replaced by sine x. So 3 sine 3 minus 1, that is 2. So sine square x. So right, sine square x into ddx of sine x. And we know that ddx of sine x is cos x plus ddx of 3. And 3 is constant. So we know that the result ddx of k equals to 0, where k is constant. Similarly here ddx of 3, that is 0. So right here plus 0. Therefore here the required derivative dy by dx which is equals to 3 sine square x into cos x plus 0. So we get here 3 sine square x into cos x. So this is here as it is. We write this here. Into this 5 to the power sine cube x plus 3 into log of 5. So we write this here into log 5. And this is the derivative of the function 5 to the power sine cube x plus 3. So again, I request you, if you like my video, please subscribe my channel. And आपको जैसा इस टाइप की वीडियो अगर आप आपको डायरेक्ट मिलना चाहिए तो आपने जो मेरा यूट्यूब चैनल है वो सब्सक्राइब करना चाहिए। सब्सक्राइब करने के बाद में जब भी ये वीडियो यूट्यूब के ऊपर अपलोड हो जाता है तब पहले आपको मिल जाता है, और आप अच्छी तरह से इसके ऊपर से डेरिवेटिव डिफरेंशिएशन की जो भी स्टडी है वो स्टडी कर सकते हैं। ठीक है, आज के वीडियो में अपने 3 प्रॉब्लम एक्सरसाइज 1.1 में के सॉल्व किए। ओके।